Hello, welcome back. Welcome back. I'm John, an old YouTuber and gamer. Yes, I got a break, but I did run out of power. This camcorder is 7 p.m. It starts getting dark. I have uploaded all this many videos, like 14 videos. And this is not the most interesting to read, but I like to finish. Now I spent so many hours. We are on page 63, but I was close to falling asleep again, and I did this clicking. And when I'm clicking, the auto read stops. When you select read the whole document, and then if you click the mouse, it will just read what you're clicking on, like one line of text. Then it will stop reading. Then you cannot select continue. So if you do that in a long document, 50 pages, you have to read page by page. That's because I have my fingers on my mouse always, because I'm computer gamer. I'm a computer player, so I always have my fingers on my mouse ready to click. And if I'm very sleepy, I click by mistake. I only do that when I'm not. I don't do that when I'm playing games. I'm not clicking my mouse when I'm playing computer game by mistake, because of course I'm not sleeping. But this one makes me sleepy because I'm laying in my bed here. So I have my fingers like this. This is how I use my mouse. I've been clicking many millions. So I have to do like this, not put my fingers like this. Normally I use my mouse like this. Then when I'm falling asleep, I'm clicking. I don't know why, but I start to do that because I'm starting to get old. But there's a lot of science behind computer processors, CPUs. I'm just trying to learn how these CPUs are working. Yes, I'm not going to take all the CPUs out again, but that's my collection of CPUs there. I'm not going to take it out again, but that's computer CPU that's building on like more than 50 years of computer science and microelectronics. That's a very big science and knowledge behind to make a computer, a CPU, central processing units. That's what I'm trying to, not just how they make it. Yes, I know I need to read about the semiconductors industries, all this. But that will take, this will take my whole summer. And I'd like to read about how you make this integrated circuit, wafers, MOSFET, how you do the CPUs, micro, I don't know why a socket catcher. Yes, but just follow my list, because this will take my whole summer to do this. And so I know this is not very interesting, but I like to read these documents, even I not understand anything at all. I like to see it, because then I understand it's very complicated. Many of this document, they are computer programmers, that's experts. That's computer programmers and experts have written. This is not for normal people. But I like to read it. Some I understand, something not. Most I don't understand at all. So, but that's the X86 instructions. That's really many, that's many hundred. And I don't know how you use these instructions. If you do the programming, how you write these instructions. I don't know, and why I don't know it, that's because I'm not a computer programmer. So I'm looking forward. I like to finish this. Then I will do the X86. That's 28 pages. That's another long one. And that's we have the assembly language. Then I will continue my lists. But that will probably take my whole day tomorrow just to do the two next PDF. That would be my whole Monday. But that's fine, I have nothing to do this whole summer. Yes, I have to read, activate, reading. My computer had crashing too, I had to open everything and read page by page.
Mode, similar to December alpha spell code, for many complicated operations that are implemented with microcode in most other X86 CPUs. The X86 provides a large number of undocumented instructions to assist hypermode operation. Swap mm/m640f0f/RBB undocumented AMD3D now. Instruction K6-2 and K6-3. Swap 16-bit words within 64-bit MMX register. 9659. Instruction known to be recognized by MARSM 6.13 and 6.14. Available on K6-2 and K6-3 only. Opcode reused for documented PSWAPD instruction from AMD K7 onwards. Unknown mnemonic 64D6 using the 64H FS segment prefix with undocumented D6 SALC /set ALC. Instruction will, on UMC CPUs only, cause EAX to be set to 0xAB6B1B07.5397, available on the UMC Green CPU only. Executes as SALC on non-amicpus.fs, JCC 64, 77F, RIL 8,640F, 88F, RIL 16/32 on Intel NetBurst. Pentium 4, CPUs the 64H, FS, segment, instruction prefix will, when used with conditional branch instructions, act as a branch hint to indicate that the branch will be alternating between taken and not taken. 98, unlike other NetBurst branch hints, CS, and DS, segment prefixes. This hint is not documented. Available on NetBurst only. Segment prefixes on conditional branches are accepted but ignored by non-NetBurst CPUs. Altints 0F3F jump and execute instructions in few documented alternate instruction set. Only available on some X86 processors made by VIA Technologies. FMA4, VEX.66.0F38. 5C5F68 6F78 7F /remate on AMD Zen 1. FMA4 instructions are represent but undocumented, missing CPU ID flag. The reason for leaving the feature undocumented may or may not have been due to a buggy implementation. 99. Removed from Zen 2 onwards. Rep XSHA512F30FA6E0 perform SHA512 hashing. Supported by OpenSSL 100 as part of its VIA Padlock support but not documented by the VIA Padlock programming guide. Only available on some X86 processors made by VIA Technologies and Gelxin. Rep XModeX 30FA6F8 instructions to perform modular exponentiation and random number generation, respectively. Listed in a VIA supplied Patch tote support for via nano-specific padlock instructions to Panzer 101, but not documented by the via padlock programming guide.xrng2F30FA7F8. Unknown mnemonic 0FA7, C1C7. Detected by CPU fuzzing tools such as SoundSifter 102 and UIS Fuzz 103. ACE executing without causing hash mute on several different via and JOX in CPUs. Unknown operation may be related to the documented XSTORE 0FA7C0 instruction unknown multiple 0F0F/R. The white papers for SoundSifter 102 and UISFuzz 103 report the detection of large numbers of undocumented instructions in the 3D opcode range in several different AMD CPUs, at least GAD-NX and C50. Their operation is not known. On at least AMD K6-2, all of Thune assigned 3 GNO opcodes, other than the undocumented PF2IW, Pi2FW and PSWAP instructions, execute ACE equivalents of POR, bitwise or instruction. 59. Present on some AMD CPUs with 3D Mod-Mul2 unknown JOX in RSA/XMUX instructions. Mnemonics and CLUID flags are listed in a Linux kernel patch for UP 104, but opcodes and instruction descriptions are not available. Unknown. Some JOX INCPAS 105 have the CPU ID flags for these instruction set. Undocumented X87 instructions. Mnemonics opcodus description status free C0 plus I same operation as FFREST I, followed by FSTPST 0. Available on all Intel X87 FPUs from 8087 onwards. Available on most AMD X87 FPUs. Unavailable on AMD GAD GX/LX, DM and PVORT X86, 106. And next-gen 586PF. 107, documented for the Intel 80287, 108, but then omitted from later manuals until the October 2017 update of the Intel SDM. 109, FSTP-NCED9D8 plus I same operation as documented FSTP-ST, I. DDD8 plus I except that it T producia stack under flow exception. Fconc D0 plus I same operation as documented FCOMST I D8 D0 plus I FCOMP DC-D8 plus I D0 plus I same operation as documented FCOMPST I D8 D8 plus IFXCHD DC8 plus IDFC8 plus I same operation as documented FXCHST I D9 C8 plus IFSTP DFD0 plus IDFD8 plus I same operation as documented FSTPST I DDD8 plus IFENI FENI 8087 _ NOPT B0 FPU enable interrupts 8087. Documented for the Intel 80287. 108, present on all Intel X87 FPUs from 80287 onwards. For FPUs other than the one is where they were introduced on 8087 for FENI/FDC and 80287 for FSEPM. Thoctors NOPs. These instructions and their operation on modern CPUs are commonly mentioned in later Intel documentation, but with opcodus omitted and opcode table entries left blank. For example, Intel SDM 325462-076, December 2021 mentions them twice without opcodes. The opcodes are, however, recognized by Intel XED.110. FTC 8087_not B1 FPU disable interrupts. 8087. FSEPM 287_not B4 FPU. Set protected mode. 80287. No mnemonic. D9D7. D9E2 D9E7. DDFC D8. D DC. D DFFC reserved by Cyrix subcodes. These subcodes are listed as reserved subcodes that will produce unpredictable results without generating exceptions on at least Cyrix 6x86, 111, 6x86MX, Me Media GX, and AMD GX/LX.112. The documentation for these CPUs all list the same 10 opcodes. Their actual operation is not known, nor is it known whether their operation is the same on all of these CPUs. See also Command, Adrand, Larrabee extensions, Advanced Vector Extensions 2, Bit Manipulation Instruction Sets, CUID, References. 1. Intel Processor Identification and the CUID instruction. Retrieved the 21st of April, 2013. 2. NEC 16-bit V-Series User's Manual. 3. NEC V30.
Yes, we not read that, and the video splits in 3 minutes. I used to scroll down to the bottom of the documents so we can see where we have read it, external link. No, this was the 13 April, last 13 April. So, but I already have it, I just close it. Next one is this one, but I don't think it will be tonight, I think. That's 28 pages, so maybe when I need a break, I will start upload this. Of course, this is not the most interesting stuff to read. But I will take a small break, then I probably could continue do this, because I had a break do this like more than 3 weeks, because I did start to play GTA 5. I was walking around the map on the island 2 times. Then I built Lego. I built all this Lego car, this Lego dinosaurus, and this Lego, and got it on video. I got 2 more boxes of Lego, I have more Lego there. I'm going to build this later. Maybe I will use this as a gift, maybe I don't build this, maybe I give it away in a gift, but I will build this car, I think I will save this for gift maybe. I don't know. Yes, but that's the part of the computer hardware. That's the instructions to the CPUs, how the CPUs are working. I not remember much of this X86, but I have to read it later what X86 is. I cannot explain what X86 is. Yes, that's architecture to the Intel CPUs called X86, but I cannot explain it what it is, and I cannot explain even I just look all these instructions. I can tell you there's a lot of kind of instructions to the X86, and that's got every generation of new CPUs. They have more instructions. I have to read it later, but now I know it's very complicated.